Okay, good morning, everyone. Okay, before we start, do you have any questions about anything? Okay, so today we're going to keep working with line, introduce linear function, and that's it. I mean, a lot, but that's what we'll be doing. So let us recall the last time we introduced line, we introduced the idea of a slope, and we start working with how to find the equation of a line. And as I said, of course, all of you have seen the equation, and the equation has the form y equal mx plus b. So I know that all of you have seen that. But the idea now how to find this equation, and there are two ways. The first way is the one I introduced last time, and that's called the slope-intercept form. Sorry, the point-slope form of the equation of the line. And this tells me that to find this equation, if I know the point, so we have a line, just a line, simple line, straight. And if I know a point on the line, and let's see, I called it x0, y0, and I know the slope. Okay, so suppose x0, y0, point on the line, point on the line. M is the slope of the line. Then the point slope form is the following. Okay. Y minus y0 is the slope times x minus x0. Okay. So it means if you take any point on the line, that's really what that means. If you take any point on the line, then this equation will give you the relation between the x and y coordinate. So that's really what this equation do that. And we did a couple of examples last time, so I will do one quick example. So let us say use the point slope form to find equation of the line that passes, I'm going to give a point. So let us say 2 minus 4. And with slope, let us say minus 4/5. Okay, that's the slope. Okay, so we're just going to find the equation. So let's do that using the point slope form. It means we're going to find the relation between any 2 points on the line, basically the coordinate of any points on the line using this equation. So let's see how the setup is. X. Here, the slope, which is minus 4/5. And this is the point. The point is 2 minus 4. So this is minus 4 here. And this is y equal to 2. Okay. And then the rest is basically algebra to rewrite the equation of the form that you are used to it. So that's how we start. And then we basically solve for y. Y minus minus is going to give me plus. Now I distribute. Minus minus, it's a plus. 4/5 multiplied by 2 will give me 8/5. And then now I take away, subtract 4, so I can write it in the regular format that you are used to. Over 5 minus 4. Now at this stage, we have to find a common denominator so we can combine those two terms. We don't leave them like that. And this would give me minus 4/5x plus. The common denominator has to be 5. So I have to multiply the 4 by 5. So 4 times 5 over 5. And finally, I will get my y equal minus 4 over 5x, 8 minus 20, give me minus 12 over 5. So it's a little bit of fraction, and that's the 4mx plus b that you usually get, but now we found it using the point-Stokes form. So what's the benefit of this equation is so if this is my line, so suppose I'm drawing here my line, I should have left more space. My point, it passes through the point 2 minus 4. So if x is 2, my y is minus 4. So that's really the point. And the slope is minus 4/5. So it means this is the delta x and this is the delta y. It means if you move 5 units, you have to go down by 4 units. So this is really my line. So this is the delta x, that's the 5. And this is the delta y, that's the minus 4, because I gave you the slope. So the benefit of this equation is simple. So suppose I want to find this point right here. What's the coordinate of this point? Quickly. So once I know the equation, I basically know the coordinate of every point on this line. So who can tell me immediately what's the coordinate of this point on the line? Anybody? I know it's early in the morning, but you guys can still answer me.
Is it minus 4?
No, minus 4 is down here. This is the minus 4. I want this point. What characterizes this point? What characterizes this point?
Oh, isn't that the y-intercept?
Right, that's the intercept. The x-coordinate is 0. Am I right? So what's the y? That's what the equation would tell you. If x is 0, the y is going to be minus 12/5. And that's what you guys, we call the intercept. So this component is going to be minus 12 over 5. That's what it means, the equation. So if I take any point on the line, if I know the x-coordinate, this equation is going to give me immediately what's the y-coordinate. So with this in mind, suppose I take the following point. Any point on the line, any point. So I can erase this because I should have had a much bigger picture. I didn't, so my apology. So suppose I take this point here. So let me call this point 4, for example. And I go down on the line, this point on the line. So what can we figure out? Can we figure out the coordinate of here? Is it now easy or hard? How would we do it? Back to you. I want the interrogation mark. I give you 1 minute to figure out this value. Because where do we find the equation? What's really the benefit of this equation? The benefit of it is that if I take any point on this line, I know what happened between the x and the y. So my question now to you is, find the missing coordinate. Okay. Whoever find it, put it on chat, and then we talk about it. Anyone? Please put your camera on. It helps me. Okay, anybody, how can I find this interrogation mark? This is the line, and that's the equation. It means that every point on the line, that's the relationship between the x and the y. If I'm asking for the interrogation mark here, it means the x here, the x is equal to 4. So really what am I asking you, if I give you the x to 4, what's going to be the y? So basically you're just plugging in 4 for x. And you are evaluating. That's really what this equation gives me. So this is going to give me minus 16 minus 12 over 5, which will give me not very nice number. That's why we need the equation, because it's hard for us to come up with those nasty numbers without the equation. Okay, so that's really the benefit of the equation. If I take any point on the line, if I know the x, then I will know the y. Okay, so that's the point slope form for the equation of the line. Now we're going to see another form, which is called the slope intercept, which is the one you are more familiar with. So the slope intercept form. Slope intercept form. Okay, so why it's called the slope intercept form? The idea here is the following. Suppose you have a line. Again, just a simple line. It can go up or it can go down. And let us say I know two things about the line. I know, so let M, we have L a line. M is the slope. And B is the intercept. What does it mean? That B is basically it's the vertical intercept. What does it mean? B is the vertical intercept. The slope is M. It means this is B. This is B, the vertical intercept. So if I say B is the vertical intercept, it means which point is on the line. If B is a vertical intercept, it means which point is on the line. You guys are too quiet. I'm trying to let you talk beside me starting picking student. If B is the intercept, it means which particular point is on the line. What are the coordinates of the point on the line? It means this point is on the line. So if I said that's the intercept, it means the point 0B in the line. And now what's going to be the equation in this case? So if we use the slope, the point slope form, okay, the equation becomes, this will be the equation that you are familiar with. The equation becomes y minus equal x minus. If we know the intercept, it means this is the point on the line. It means y minus b equal x minus 0. That's the slope and that's the point. So now we can derive the equation that you are familiar with. Y equal mx. And now if I solve for y, I will get mx plus b. That's the other form that you are familiar with. So m is my slope. B in this equation is exactly the vertical intercept. What does it mean? It means it's the output value, or it's the y value when x is 0. So the B is the y value when x is 0. So now we're going to do two problems. And which form to use to find the equation of a line? You can use either one. Either you can use the slope intercept, or you can reuse the point slope form. Usually, as I said last time, in a calculus course, we tend to use the first one because it has a specific meaning for us. All right, so now I'm gonna do the following problem. So find equation of the line that passes through, equation of the line with slope, okay, with slope, let us say 5, and intercept and vertical intercept. So it's a and vertical intercept 3. Okay. So what am I asking you about? Which line I'm talking about? I'm asking you to find the equation of the line. The vertical intercept, that's the vertical intercept. That's 3. And the slope is 5. It means if you go by 1 unit, you go by 5. So that's the slope. That's the line. Okay, we need to find the equation. It means I need to find the relationship between any 2 points on the line. All right, I'm going to use the slope intercept form. So here M is 5. Okay, so we're going to use this form to find the equation. M equal to 5. The B is the y-intercept. That's the B is equal to 3. So this equation will become immediately 5x plus 3. So that's the simplest possible scenario to find the equation of the line. If, by luck, doesn't always occur, if you have the slope and you have the intercept, immediately there is nothing much into it. It's 5x plus 3. Okay, now the second question along the same line, and then we stop with this equation stuff. So the second equation is use the slope intercept. It means, I mean by that the form y equal mx plus b to find equation of the line that passes through. I'm going to give you 2 points that pass through the following point. 2, 4, and 8, for example. All right. And this time I want you to use the slope intercept to find it. What do I mean by the slope intercept? Okay. We know how to use the point slope, the slope intercept. The slope intercept work like this. It tells me that the form is y, that's the one you should know. The form is y equal mx plus b. So to find the equation, I need to find the slope and I need to find the b. Okay, first let's go after the slope. The slope is 8 minus 4 divided by 5 minus 2. So it's going to give me a 4 divided by 3. That's the slope. Now we need to find b. Okay. All right, how do we find b? Okay, to find b, we say the following. Okay, y is 4 over 3x plus b. That's really the form. And we say that, you know, the point 2, 3 is on the line. 2, 4. I pick one of the points on the line. It means that if I plug in 4 for y and 2 for x, the equation should be satisfied. And then I solve for b. So I repeat, to find the equation, you can go 2 ways. Either you use the point slope form, which is you don't have to solve for anything. You just plug in into it, which is, I think, the easier one. Or you can use this format. We're going to do it just so in case you use it, you know exactly how to use it. So this form tells me, you know, the form of the equation is mx plus b. So to find this, I need m and b. M, I have 2 points, so m is easy. To find b, you say, okay, I know that the point 2, 4 on the line, so if I put y, 4 for y and 2 for x, this equation should be satisfied. and I use it to solve for b. So the rest now is solving. 4 third times 2, that's 8 over 3 plus b. I need to solve for b, then I subtract 8 third, b equal 4 minus 8 over 3. Now I need a common denominator. My common denominator should be a 3. Then this would give me 12 minus 8, 12 minus 8, 4/3. And now my equation would be y equal my slope plus 4/3. It's just coincidence that the slope and b have the same value. Okay. Any questions so far? Very good. Okay, so now we're going to go on along the same line. So let me summarize how to find the equation of the line. You can go two ways. Either you use the point slope form, or you use y equal mx plus b, and then you proceed. But regardless how you find the equation, regardless how you find it, whether you use the point slope form or you use the slope intercept, the equation will end up looking like this: m, which is the slope, times x, and the power here is 1, plus b, where b is in the intercept. So it means regardless how you do it, you're going to end up with something like this. B is here because b is the output when x is 0, and then the line is either going up or down depending on the slope. Okay, so with this in mind, I'm going to ask you a few questions. So I'm going to give you a bunch of equations, and I want you to identify the slope and the intercept. So the question is: find slope, the vertical intercept, and let us say sketch the line. Okay, so we're going to do all of them. So I start with the first question, the very simple one. Suppose I give you y equal 2x plus 5. And our question is simple. Identify the slope, the intercept, and then you sketch. So very quickly, what's the slope?
2.
What's the vertical intercept?
5.
Which one, 5? The intercept?
The intercept is 5 and the slope is 2.
Right, the slope is 2, because the slope is whatever x is multiplied by. That's the slope. Whatever x is multiplied by is the slope. The intercept is, you can just memorize 5, or I don't like to memorize. I said, okay, the intercept is the y value when x is 0. So for the intercept, basically, you're going to set x equal to 0 and find what's the value. So in this case, the intercept is 5. Okay. Now sketch the graph. How do you sketch a line? So once you recognize it's mx plus b, the graph has to be a line. It means it doesn't curve. That's what really I mean by that. So how would you sketch a line?
Mark the y-intercept at 0, 5, and then just use the slope 2, up 2, and
yeah, we can do it 2 ways. Absolutely correct. We can do it 2 ways. One way is, that's your classmate said. Okay, so the slope is, the intercept is 5. It means that's what it intersects. The slope is 2. It means if you move by 1 unit, you have to rise by 2 units. That's the 2 here. Absolutely correct. That's one way you can draw the line. Another way, when you are dealing with nasty numbers, like the slope is 2/3, 5/5, sometimes another way to do it, another way is actually it's a line. So, or you can just pick 2 points on the line and sketch them, because a line is determined by 2 points. So, or you can do that. We can figure out 2 points and then sketch. I say, okay, let me find 2 points. So y is 2x plus 5. So we can do it both ways. x is 0, y is 5. That's a point on my line. Then you say, okay, let me figure out another point. So pick any x, okay? You want to pick x to be 1? Fine. That's 2 plus 5 equal to 7. So if x is 1, this is 7. So that's going to give me 1, 7. Therefore, I have my line. Okay, so to sketch a line, either you go following the slope or you pick 2 points on the line, which is sometimes this will be easier for you. Sometimes picking 2 points will be easier than only picking, figuring this intercept and the slope. Okay, so that's 2 ways of drawing the line. Right, so now that we've done drawing the line, now I'm gonna move on and ask you the same type of questions. Y equals 6 minus 3x. Quickly, what's the slope and what's the intercept?
The slope is -3, and then the 6 is the intercept.
Right, the slope is whatever x is multiplied by. X is multiplied by -3. The intercept, you set x equal to 0. You either look at it or you said that's what happened when x equal to 0. That's always remind us what really the intercept is about. Is the y value when x equal to 0. All right, 2 more questions along the same line. And you, in your homework, you'll have more than that. Suppose I give you the following. Sometimes the equation of the line is not given in the form y equal mx plus b. It's given in a more disguised way. So for example, suppose the equation is given into this form. Okay, that's also an equation of a line. So instead of giving y equal mx plus b, they give it you in this format. So how can we figure out the equation when this is the form? How can we figure out the slope and the intercept when this is the form of the equation?
Wouldn't you subtract y from both sides?
And the goal of, yes, what's your goal?
The goal is to isolate the y so you can create the slope intercept form.
You right? It's exactly what you're in the form y equal mx plus b. That's the only way we can figure out the slope. All right, we have to rewrite it. All right, so one way to rewrite it, I wouldn't take away y because I want the y to be positive. What shall I take away? I take away
3x minus
3x, right? I take away the 3x. So and then I add the 5 from both sides. Okay, that will make it slightly easier. Once I rewrite it this way, I'm done. So the slope is -3. And the intercept is 5. X equal to 0, y equal to 5. Okay. So one more. Suppose I have 2y, and why not, plus x plus 3 equal to 0. Okay, I give you a minute to figure out the slope and the intercept. Okay. Anyone?
Would it be -2x minus 6?
No. And I know what your mistake is. I know what your mistake is. See if you can figure it out. Everybody else. Anybody have? Yeah, now we're starting. We're starting. Yep. Okay. So we're doing fine. So we're going to do exactly what we did before. We need to isolate the y. So first, I'm going to keep 2y on one side and then take away the x from both, take away dy. Okay. But then, exactly. And you don't have to divide by 2, not necessarily. First, isolate 2y. And then we're going to divide, because it's 2y, I cannot really, then we're going to divide by 2. Divide by 2 and not multiply. That's the mistake. It was done. So I divide this by 2, it's going to give me a y equal. When I divide by 2, I have to divide across the board. I don't divide sum and I forget about sum. So I'm going to have minus x over 2 minus 3/2. Okay, so now we are basically safe. Now minus x over 2, I'm going to write it minus 1/2 times x. And the reason I did that, I want the slope to actually kind of shine by itself, minus 3/2. Okay, and now we are actually there. It's done. So the slope is whatever x is multiplied by. So now the slope is minus 1/2. And the intercept is what happened when x is 0. It's minus 3/2. Minus 3/2. Okay. So if you have this equation, you know what your classmate said, do you divide by 2 first? I wouldn't do that. It makes it harder. First, I isolate the 2y, and then I will divide by 2, giving me the answer. Right. There are more properties of lines that I will be talking about later on, because now I'm going to pick up about linear functions, because linear functions are too much related to the idea of a line. So what's a linear function? So remember, a function is a rule. You give it an input, and it's going to spit out a certain output. That's really what a function we've been doing. So what does it mean to tell you this function is linear? What are they talking about? So linear function. Somebody tell you, okay, this function is linear. So we're going to have different definition of linear, which are equivalent. Okay, a function is linear. So a linear function is a function whose graph, exactly what you guys said, a linear function is a function. It means it's a rule. But when you graph it, you get a line whose graph is a line. So very particular type of function. Not every function, when you graph it, you get a line. A lot of functions are going to curve. Linear, it means when you graph them, you get a line. So now, since the graph is a line, because when you graph this function, so this is the x value, and here were the output value, since you're getting a line, then we can find a formula for it. Not always we can find a formula for a function. But the function is linear, the function has a formula. So since the graph is a line, that's crucial, then the formula will have the form. So what does it mean, a formula? It means if you have a point on the line, that's what means a formula. And if you have the input value, can you give me a formula to find the output value? And if the graph is a line, then the formula has the form. The formula is nothing more than the equation of the line. So it's going to have the form, the output, it means the y value is always the slope times x plus b. So if a function is linear, the function has a very, very definite formula attached to it. It means the output value, it means the y value is always mx plus b. So we can really work with them. So first, a very straightforward example, and then why do we care about linear function? What do they model for us? So first question is what we've been doing. So example, let f be a linear function. Already I'm telling you a lot. The minute I write linear, I am already telling you too much about the function. It's a line, and I know the formula for it. Let f be a linear function, and I'm going to give you some values of it. So some values of f are. Okay, I'm going to give you some of their value. It means some input-output values. So I using exactly the notation in the book, so you guys will be familiar with that. So x, bunch of input, and these are the output value. And I tell you at -1, the function takes the value 2, it's linear. And at 3, the function takes the value 6. So I'm telling you that it's a linear function. So it means when I'm going to graph this function, what's going to be the graph? The function takes -1 to 2. -1 is going to take it to 2. That's the 2. Actually, I'm going to put the 2 a little bit lower. So it takes -1. Okay, -1 to 2. So that's a point. That's it, 2 here. I take 3 to 6. 1, 2, 3. 6 is up here. So it's going to take 3 to 6. So these are 2 points. Telling you linear, it means they are telling you that when you graph this function, you get a line. Now, by doing this, you should have all the information about the function. So question number 1 is, find a formula for f of x. For the function. What does it mean, find a formula? It means give me the rule that if you know the x, the rule will have to give you f of x. So find a formula, it means give me the rule that f of x is governed by. Now, we say that since it's a line, f of x is equal to mx plus b. And how you find the equation, now you have a choice. Either you use the point slope form or the slope intercept. I don't care which one you use, okay? So first I need the slope. What is m? Okay. The slope is, these are the 2 points. So the 2 points I have are -1, 2, and 3, 6. Those are the points. So the slope is the change of the output. Remember, these are the output value. It's 6 minus 2 divided by the change here, which is 3 minus -1. It's going to give me a 4 over 4. It's equal to 1. So my slope is 1. Now I need the equation. So I need f of x equal mx plus b. So let us use the slope intercept. So we need to find the b. Okay, and I take another paper, so I don't really put a lot of stuff together. So we're going to find the b. So find b. Now to find the b, I say, okay, I need a point. I know that, pick any point you want. Any point you want. I say, okay, f of x is mx plus b, but m is 1. It means the function has the form x plus b because m is 1. Now to find b, I say, okay, the point on the line, -1, I pick any point. So let me pick 3. I say 3, 6 on the line. What does it mean? It means if x is 3, f is 6. So I plug in those values. And now I solve for b. Means b equal to 3. So f of x equal mx plus 3. That's the formula for the function. All right, so it's just finding the equation of the line. So finding the formula, it means finding the equation of the line. You can either find it by following the slope intercept or the point slope. Now, question number 2, now along the same question, suppose I tell you, so it's the same function. Find f of whatever, pick any number. Find f of 17. This is an easy or a hard question. So I have the function is linear. I have 2 points on it. I'll tell you find f of 17. Okay, now the question is fairly easy because I know I have a formula for it. So I want f of 17. I said, okay, f of 17 equal 17 plus 3. This is equal to 20. Okay, so once I have the formula, I know the output regardless what my input is about. All right, so that's what a linear function is. Okay, now the question is, if, let us say, the function model like population growth, what does it mean to say that the graph of the population is linear? What does it tell you about the population? Okay, the question number 2 is basically, what do they model? I mean, what's important about them? So let me ask you simple questions. I mean, let's do simple problems. So what characterizes linear function? Linear function. You know it, but we're gonna put it in words. Suppose you have a linear function. I'm gonna sketch 2 graphs here. It means the graph is a line. Okay. So that's linear. Non-linear, it means when you graph the function, you don't get a line, you get a curve. That's non-linear. So linear versus non-linear. All right. What characterizes linear function? What characterizes it is the following. Some things that we know. Suppose the slope here, let me mark up any number. Suppose the slope is, I don't know, 3. I mean, just making it up. What characterizes it? Means if you start any point on the line, any point on the line, and you move by 1 here, you're gonna, the output. So this is the input values, and that's the output value. So if the input value increases by 1, the output in this scenario will increase by 3. If I start any point here, again, if the input increases by 1, the output is going to increase by the same amount, which is the slope. So if the graph is a line, and that's crucial. So when the x value or the input increases by 1, the y values or the output, if you want, increase by the same amount, which is, in this particular problem, the slope, increase by the same amount. Basically, in this problem, in the picture, it's 3. In the graph given, it's 3. Okay, so the rate, you can think about it as a rate. It means the rate of change of the function is actually constant. It means the rate of change is constant. What does mean the rate of change is constant? It means your output changes by the same amount every time your input increases by 1. Your x value increased by 1, your output increased by 3. Increased by 1, increased by 3. It means the function changing, but at the same rate, by the same amount every unit of time. Now, graphically, if the function is not a line, I just want you to see graphically what really happened. Watch carefully. If I start a point and I move by 1, just the graph, my y is increasing that much. If I go another 1, the y will start increasing more. It's not by the same amount. If I keep going into the graph, I increase by 1, the same amount, look how much the y is changing. So when the graph is not linear, if the x value increased by 1, the y value does not increase by the same amount. It increased by different amount. So in this case, the function doesn't change at the same rate because it does not change by the same amount every unit of time. So in this scenario here, in this scenario, the function does not change. So the rate of change means how fast the function changes is not constant. It's not the same. You go by one, you go by that much. You go by one, you go by my one. So that's one of the most interesting things about linear function. In linear, the function changes at a constant rate. Every unit changes by the same. However, it doesn't do that when it's not a linear function. It means when it is curving. So we're gonna basically work with this idea for the remaining of the lecture today. So the first set of problems are actually, I mean, this whole section is not hard. The first set of problem is simple. So I'm gonna give you a bunch of functions and I'm gonna tell you which one do you think is linear and which one do you don't think it's linear. So which of the functions below, so question number one, which of the functions given below could be linear?
I have a quick question.
I'm listening.
Is this lecture a continuation of 1.11 or is this?
Yes. 1.11 basically is putting everything you know about line in one section. Are you with me?
I was just wondering if this was like 1.12 or
No,
something.
it's 1.11. It's everything. I mean, it's honestly everything you've ever seen about lines is in this section. So that's why I'm breaking it into pieces because otherwise it doesn't work.
Okay.
Okay. All right. So which of the functions below, given below, could be linear? So I'll start with, and my functions now, I'm not going to graph them because graphing them, if a line is a line, we know it's linear. If it's a formula, we know because it has to the form mx plus b. So if you have a table, this is the input and this is the output. This is the x value and this is the y value. So, and I'm going to give you a bunch of values, fairly simple values, nothing deep here. And I give -1, 6, 13, and 20. So the way we read this is a function. It takes 1 to -1, 2 to 6, 3 to 13, 4 to 20. And my question is, with this data given, do you think the function is linear? It means, yes, because
it's increasing by 7 every time.
right. And the input is increasing by what? We have to always be careful with the input.
By 1?
By 1. It's crucial. And now it's increasing by 1. And this is increasing by 1. And the question is the output, is the y value increasing by the same amount? Okay, from -1 to 6, it's 7. From 6 to 13, 13 is increasing by 7. And it's increasing by 7. So here, when you're graphing, at least with this given data, we don't know what's going on after that, it's definitely a linear function. So here, the change in x is 1, and that's crucial. And the change in y is constant. So that's a linear function. And what's the slope of this linear function?
+7.
It's absolutely a 7. Okay, so that's absolute a linear function. So I can break linearity fairly simply. So I can basically break linearity, and you guys can break it for me easily. So suppose I'm going to make up an example where linearity fail. So I'm still going by 1. I'm going by 1. I'm going by 1. And then I'm going to change. I'm not going to go by 1 anymore. So how can linearity fail? What should I give 4?
21.
Anything but 20. That's not linear. Because here I'm allowing the x value to increase by 1, but my y value is absolutely not increasing by the same amount. Means the minute you graph this, we're going to curve. The minute you attempt graphing, the function will curve. And this is 8. So it's not the change in y is not here. Basically, it's not the change in y. The better way to put it, the accurate way is the change in y over the change in x is not constant. And I'm going to move to look at is not the same because it's 7 here It's 7 here, it's 8 here. Forget it, it's not constant. All right. 2 more examples. Now, in those, I gave you the change in x to be 1. I don't have to. I can change, I don't have to give you the same change in x. But how do we check in this case that the function is linear? So if the table, if delta x is not constant across the board, to check f is linear, we make sure that the slope is constant. We look at the slope. It means the delta y over the delta x, and we see if it's constant, if this is constant. So if the delta x is not constant, the way to check linearity is basically look at the slope itself and ask yourself, is the slope constant or not? So a very typical scenario for that is the following. Please, when I turn the page, let me know if it's all right. So let me make up a scenario here. I don't know. So suppose I give you the following function, x and f of x. And I want the function to send, so these are the input values. And those are my output. And I wanted to send 0 to 3. I wanted to send 2 to 11. And I want to send 3 to 15. Okay. So is this linear? Now here I jumped around. So from here to here, the change is 2, so it's not 1 anymore. The change here is 1. So I'm not really keeping the same change in x. So in this case, I have to see is the ratio, which is the slope between the change in y and the change in x is actually constant. So I'm going to compute here between 3 and 11, how much y the output changed by. 11 minus 3, let's give me an 8. And from here to here, the output changed by 15 minus 11, which is going to be a 4. So now we're going to compute the average rate and see if the slope is constant. So between 0 and 2, the change is 8 over 2, which is 4. And between 2 and 3, again, we compute that. It's going to give me 4 over 1, which is equal to 4. It means that this function could be linear. It's a good candidate. So if I take the graph and I draw those points and I try to connect them, they will all live on the same line. That's going to be the graphical effect. So those particular points, if I graph them, so I mean by that the following. If I take 0, it takes it to 3. And 2, it's 11. So my graph is not good. So 3, if this is 3, 3, 3, I need a better graph. I need a better scale. Okay, so if I go by 5, this is my 5, and 10, and 15. And then at 0, I am at 3, so somewhere in here. 2, 1, 2, and 3. At 2, I am at 11, somewhere in here. And at 3, I am at 15, somewhere in here. Those points will live exactly on a line. There is no curving or whatsoever. Okay, so what's happening here is that the ratio, that's what we are computing. So this is my 11 and this is my 15. And what we computed is the change in y, in this case, which is 8, the change in x, which was a 2, the ratio here, and the ratio between the change of y and the change in x is constant. That's typically a line. So that's really what characterizes a line. Okay. So now let us see what type of story problems will fit the scenario of a line. So now we're going to take very simple, nothing really hard, very simple, story problems where the scenario is actually a line. So let's start with that. And every time we're going to do the following. We're going to find the slope of the story and we're going to give a unit to the slope because so we can make sense out of the slope. So I start with the first problem. Again, simple scenario. All right. I read it. I forgot to put this worksheet on bright space. I will put it after the lecture. The typical scenario of linearity. So I tell you that in the year 2000, the population of a town was 5,000. That's in the year. Since then, the population has increased by 50 people a year. So initially, we had 5,000 in the year 2000, and it's growing by 50 a year. And this increase is expected to continue. So 50 every year. And let t be the function. Let t represent time in years after 2000. So t equal to 0 represent 2000. And f the function that is assigned to t, the population of the town t years after 2000. Okay, so here I have a rule. I have a function. And it is assigned to time, so you input the time. It is assigned to it the population at time t. And t is how long after 2000? So t equal to 0 will correspond to the year 2000. Okay, so it's a population that's growing by the same amount every year. So my first question is basically fully understand this function. So at t equal to 0, what is f of t quickly?
5,000.
5,000. At t equal to 1, what's f of t?
5,050.
That's the population is growing by the same amount, exactly the same amount. After 2 years,
5,100.
5,150. The same amount every year, the same amount every year. So is this a linear function quickly?
Yes.
Is the population growing linearly?
Yes.
Absolutely, because it's the same amount every unit. That's linear growth. It means every year, that's exactly when we say something is linear, the population is growing linearly. That's what you should understand immediately. It means it grows by the same amount every year. That's linearity in simple story. Now find a formula for f of t and sketch the graph. So find a formula. So f of t is linear. Because it's linear, it means that it's governed by the same formula. That's the relationship between the population and the time. It's m times t plus b. That's really the formula. Now, of course, when I tell you find the formula, you know to write that, you have to find every aspect of it. So what is the slope in this particular problem? Because it's a simple scenario. And what's the b in this particular problem? What's the slope here? Back to you. 50, is she correct? The slope is, if you ever forget, is the change. So here, the population, I take any 2 point and 5 the change, minus 5,000, that's by how much it grew within a year, divided by 1 minus 0. So that's equal to 50. So the slope is really how much is growing per year. and B is the output when t equal to 0. So in this scenario, I gave you that. So in this particular scenario, B is the value of the function at 0, which is 5,000. So my formula now in this, again, in this scenario is going to be f of t equal 50t plus 5,000. The most simple scenario for linearity. So if you have something that's growing by the same amount every year, then that's what linearity is about. So on the picture here, if I sketch the graph, initially, so that's 5,000. That's the initial value. And then every year is growing by 50. Every year is growing by 50. Every year is growing by the same amount. That's a linear behavior. That's what it models. Now, the second question is identify the slope, give it unit, and explain its meaning. And this is the question I always ask. I want you to be able to give me a unit for the slope. So what's the slope in this problem? 50. And now, what do you think the unit for the slope? What does the slope represent? Back to you. It's like average rate of change, but in this case, the rate is constant. So what's the slope? Who would like to interpret the slope for me? Anybody else? What does the 50 represent? What's the unit? 50 represent people, 50 people, but not only 50 people. 50 people per year. So what the slope represents is the following. It tells me every unit of time by how much your output change. So it's going to be people, how many people change per unit of time. So what's explain its meaning? It means tells me that every year, it's a constant rate. Every year, the population changes by 50 people at a constant rate. The rate is constant. That's what the unit is. So the unit is people per year. It means every year the population changed by that much. Now D is, sorry. In what year will there be 10,000 people only in the town? What am I asking about? When will there be 10,000 people? What do you
2001,
do? What?
2100.
How did you get that? I didn't do it.
I just did 50 times. I just assumed because I just did 50 times 100.
Okay, I don't want that. What if
I-
the numbers are harder?
I just estimated pretty much.
Yeah, I know that. Yeah. What if you cannot estimate? What is hard to estimate? How would you do it? Everybody. Well, it's hard to estimate. Estimation is good, but what if it's hard to do that? How would we do it?
Would you would you substitute 10,000 instead of 5,000 in the equation?
No.
I don't.
Keep thinking. Keep all of you.
Can you do 50t plus 5,000 and then set it equal to 10,000?
Exactly. That's the way we're going to do it. What year will the population be 10,000? Now, what does f of t tell you? F of t tells you that every time t, the population is given by the formula 50t plus 5,000. That's the rule. In what year will be 10,000 people only in the town? To be able to do that, it means they are asking us to do the following. Find the time, which is something we've done before. Find the time t such that f of t is 10,000. That's really what the question is. They're going to give us an output of 10,000, and we need to find the time when this is occur. So how we do that? We're going to set 50t plus 5,000 equal 10,000, and so 40. Okay, so that's, we're gonna do that in a very systematic way, because if we guess, sometimes our guess doesn't really get us far because it could be hard. So the question now, I'm giving you the output. I'm giving you the number of people, and my question is find the time when this occurred. So now solving will not be hard at all. We're gonna take 5,000 from both, I take 5,000 from both sides, 10,000 minus 5,000, I will get that. I divide by 50. And as this 50 will go, this will give me 100 years. Okay, so it means the population will be 2,000 in 10,000 in the year 2100. So this will occur because t equal to 0 is 2,000. So this will occur in the year 2100. All right, so that's a typical scenario for a linear growth or a linear decay. It's something that grows by the same amount, at the same rate. That's really what matters. Every unit is growing by the same amount. That's why that's linearity in rate. So whenever you see something linear, it means that's what you should understand. It means it grows by the same amount all the time, every unit of time. And the unit of the slope is by how much it's grow per unit, how much it grow or increase or decrease per unit. Right. Okay, number 2. I would like to do 2 and 2 and another one. It's along the same line, so but let's see what is it talking about. In the year 2010, the value of a car was 30,000. So imagine like a small Toyota Corolla. That's what's the price of it. Since then, the value of the car was decreasing by 4,000 per year. And this decrease is expected to continue. So what do they mean by that? They expect to decrease by 4,000 every year, and that this will continue. Let t represent time after 2010, and f is the function that is assigned to t, the value of the car, t years after 2010. The question is, find a formula for f of t. Okay, question, is this a linear behavior? Yes or no? Because what made it linear behavior? What's in this problem tells me that it's a linear behavior.
It's decreasing by the same amount each year.
Because it's telling me that the decrease is expected to continue. So they are telling me that the same decrease is expected to continue. So let us pick up some of the value of the function. So my function, this is a t, this is f of t. So I'm picking up value so I can really understand it. 2010, t is time after 2010. So 2010 for me is the year 0. So initially the car was worth 30,000. And then every year they are telling me it decreased by 4,000. Means after 1 year, the car by 4,000. Means the value of the car is now 26,000. And this decrease continue. So that's f of t is definitely a linear function. Is linear. Now we need to find the formula. The formula is very easy in this particular scenario because here the slope is minus 4,000. And the intercept is the output at 0, which is 30,000. So my function now here is minus 4,000 t plus 30,000, which make a lot of sense. I mean, it's really, really, if you think about it, this formula makes tremendous sense because at 0 is 30,000. When t equals 1, you're taking away 4,000. When t equal to 2, you're starting taking away 8,000. This really makes a lot of sense. It's 30,000. After 1 year, you take 1,000. After 2 years, you're taking 8,000. 4,000 the first, 4,000 the second. So you're taking 8,000. 3 years, you're taking 4,000 times 3, and so on and so forth. Now, my question to you is, what's the unit of the slope? So that's the value of the slope. What's its unit? What does the 4,000 represent?
Amount of value loss per year.
So it's what the unit's gonna be? Dollars per year. Every year, we're going down by 4,000. Every year, we're going down by 4,000. So if I ask you interpret the meaning, you ask yourself, okay, it means as time go by, every 1 year, what's happening here? The value is going down by 4,000. You always draw this little graph. Every year, the value. So that's going to be minus $4,000 per year. So that's linearity. That's really linear. That's why, that's what it models. That's the important part of what it models. All right. Okay, I will do one more and then I will assign, I'm going to assign a lot of problems. Okay. Number 3. Okay, I read it. In the year 2010, the value of a car was 30,000. The value of the car decreased by 6,000 in 5 years. So let us see what's really going on. So this is the time and that's the value. I'm trying to understand. In 2010, it was 30,000 and the car decreased by 6,000 in 5 years. Let T represent years after 2010. So if this is after 2010, it means T equal to 0 is 2010. Means my value here was 30,000. And it decreased by 6,000 in 5 years. It means after 5 years, it went down by 6,000. That's what's happening. So what's the value after 5 years? So 30,000 lost 6. So I'm left with 24,000. Okay. Let f be the function that is assigned to the value t, the value of the car after 2010. Assume f of t is linear. So when I tell you assume f of t is linear, what they are telling you in terms of the car?
It decreased by the same value every year.
That's what they are telling you immediately. It doesn't have to be the case. Usually in real life, it doesn't decrease by the same amount. In this particular problem, I'm telling you it does. Find a formula for f of t. Okay, I give you a minute to figure it out. And then we'll convene. I don't have more than that. Okay, did you guys get the formula? Right, what's the slope? Anybody found the slope? Okay, almost correct, not quite. The first answer is missing something. The second answer, I don't know. So what's the slope? Let's compute it. The function is linear, and these are two values given to us. So I'm not giving this problem doesn't give you the behavior every year, after 5 years. So what's going to be the slope? It's going to be 24,000. No, so be careful. Everybody's answering. Make sure we minus 30,000. That's the slope. Divided by 5 minus 0. Okay, so it's going to give me how much? Minus 6,000 divided by 5. Because this time, I did not give you the behavior per year. I gave you after 5 years. Now, if I divide 6,000 by 5, I get minus 1,200. The minus is crucial. Why it is minus? Because it's decreasing. The slope will have to be a negative. So this tells me that the car is losing $1,200 every year. Linear. So that's my slope. So what is my f of t now? This is still a simpler problem because I'm giving you the value at 0. If I did not give you the value at 0, then you have to solve for the b. So in this case, so it's minus 1,200 t, that's the slope. And the b in this particular scenario is what happened at 0, which is the 30,000. Because the b is always the output at 0, which is 30,000, plus 30,000. So that's the formula for the value of the car. So it means if I give you any unit, any time, if they tell you what's the value of the car in 2020, it's easy. You just plug in 2020 is 10 years after 2010. You plug in 10 in here and you can find the time. So identify the slope. So the slope is minus that. That's the slope. What's the unit?
Same thing as the previous problem, money per year.
Money per year, exactly the same thing. It means every year, constant rate. Every year, the value of the car loses, the output, loses $1,200 from its value. In a linear way, by the same amount every time, okay? Right, definitely I have to, yeah, time's up, right? Yeah, I have to stop now. So I'm gonna assign a bunch of problems from next time from the book. Please do them. And I will assign one extra problem myself. And I really want you to do it because it helped you more and more understand the meaning of the slope. So other thing, if my memory is right, you have a quiz next Tuesday. So do the practice problem. That's for Tuesday. And you have a quiz. Quiz will cover what we've done so far. It will cover average rate of change. Make sure you go over them, you study them again. And then it will cover lines, what I did so far, and linear function. Okay, so please review average rate, all the problem we did, and do all the problem with line and linear function, all right? And on Tuesday, I will finish this section. I still have one part of it. I will finish it next time, all right? And remember the online homework. It's due tonight. Online homework, please make sure you do it. I looked up last night, a lot of you haven't done it yet. Please do the online homework. It helps you review average rate extremely well, and you will be fine, okay? All right, so any questions? For those who have any questions about the online, they can stay with me, and and I can answer their questions right now if they want to, right? And the rest can leave. Okay. Anybody has any questions about the online homework?
Yeah, I still have a question about the homework.
Go ahead.
I
Matt?
know that we I know that we went over it last time,
That's
but
okay.
I'm having trouble graphing question number 6.
Okay.
I believe that I solved the answer correctly. I'm just not sure how to graph it.
Okay, shall we go to, okay, I will connect you to Moodle. I will share, oh, sorry, I have to stop the recording.